Welcome back. In this video, we're going to look at how to get smart with your debugging in LabVIEW. So I want to make sure everyone's clear about checking for broken run arrows at the top of your programs, and then using the error list to figure out what is making your program break. When you hand in a program, if it doesn't run, that is worth almost no credit. So you want to make sure that your program runs. One of the number one reasons a program gets errors is because you have a broken wire from something that you've removed or a stray wire somewhere. So there's an easy cleanup for that. And I want to show you how to remove broken wires. Also, when your program runs but it doesn't do what you expect it to, there's this excellent tool called the Highlight Execution tool. And in that, you can look at your block diagram, follow data around the program, and try to find out where it's going wrong. So, maybe it's a conversion factor or a calibration, or maybe you just wired the wrong things together. So this is an excellent tool for seeing how your program's running. And then there's a context help that I want to make sure everyone's aware of. I showed you the search function in the very first video, but the context help provides help on whatever it is your mouse is pointed to, which is amazingly easy to use. So we're going to take a look at this in LabVIEW. You will probably recognize my test VI here, right? And so I've got my simple program. And let's say, so I'm going to show you a tool right now. I'm going to right-click on my math tool, and I'm going to replace using the numeric palette. And I'm going to, instead of square it, I'm going to grab the increment tool, which just adds 1. I'm not going to change my label because maybe I just grabbed the wrong tool. So I'm also going to go ahead and try to wire my input to this. Okay, suddenly all my wires broke. I've got a red X, and my run arrow is broken. So are these artificial errors? Absolutely. But if you see dashed lines instead of wires, if you see a broken run arrow and it says, wiring errors, then you'll need to debug what is broken about your wires. Now in this particular case, it's probably going to remove all of my wires. Let's see here. I'm going to remove broken wires, which is Control B. So the shortcut for this, let's see if it works on this particular error. Yes, it does. So every wire that was broken, which because of the way I did it was every wire, was removed. I can Control Z to undo something, but I can Control B to remove broken wires. Sometimes it's easier to remove your wires and put them back than to figure out why it's broken. So I grab my input X and put it on my multiplier. I grab my input X and add it to my chart. I'm going to now check my run arrow. I fixed it all, right? So I list errors. I have an unwired or bad terminal, so I show error, and it highlights my timer. That error, that wire got disconnected with the broken wire cleanup, so I add that back in, and now my run arrow is fixed. So every time you have a broken run arrow, you click on it, you get your error list, and that will help you go around your program and fix it. The very first skill you need is, how do I make my program run? Now, I'm looking at the user interface, I'm running, and 6 squared is not 7, and 10 squared is not 11. So clearly I have something wrong here. Now maybe this is someone else's program, or it's a lab and you're looking at a group program and you can't quite figure out in the mess of programming where it's gone wrong. This is very simple, so I can see it, but what if you can't? There's a highlight execution tool right here on your heads-up display, and what it does is it shows you the value. It comes over here and shows you the value, and it's anywhere there is a value. This is false, this is 500, this is 10. As I change my input, my numbers here change, and suddenly I'm like, oh, of course, 12, 13. I have the wrong math tool right here. When you have 16 math functions and a whole lot more going on, following data through the program is the easiest way to figure out, oh, I got my X and Y backwards on a multiplication tool, or I'm changing from inches to centimeters, but my conversion factor is upside down. So this is one of the easiest ways to do that. You'll notice it slows everything way, way down, right? So if you have a lot going on, it might take a whole minute to run the entire program because it's very slow. If you find your program's running very slow and you can't figure out why, double check that this is off. So now it will run at normal speed. I can stop my program with my stop button, come back here, replace using the numeric palette, and I think it's going to be off the screen, but I'm going to go find that square again and try it again, and 17 squared, 10 squared, right? So now, oh, right, now it's working properly, okay? So we turn off highlight execution, we stop our program. The last tool that I want to show you in this debugging video is if you come up to help, there's a big LabVIEW help file. It's full of information. It might not be the easiest way to start. Context help here simply adds a box in your window, which is off my screen. Let me go find it. Here we go. It's a box in my window. I can resize it if I want it. Oh, maybe I can't. It shows me whatever the last thing I hovered over. So I put my mouse over input, and this is telling me it's a double input, which is 64 bits. If you remember anything about memory of variables, that's telling you how big the memory space is for this input. This is a waveform chart. We get the quick help. Now, there's also a detailed help link here. So now I don't have to navigate the LabVIEW help file. I can just use the context help to get close and click on detailed help. X squared. Maybe I'm confused about what a math tool does. Or maybe I can't remember what the MS means behind weight, right? I haven't had my coffee today. What do you mean? Wait, what? Wait milliseconds. I forget the stop condition. Or how the while loop works. What is I? Well, it's just giving me the same while loop. So now I go to detailed help. And let's see where that opens. Okay, and now I get the components. This is the while loop. This is the iteration terminal, which tells me what loop I'm on. This is the conditional terminal, which tells the while loop when to stop. And there's my control. So context help is probably I don't know, I'll say superlatives all the time. It's one of the best features of LabVIEW that just makes it really easy to navigate. So if I threw in, let me come here to my functions and numeric, and I'm trying to do some compound arithmetic. Now I pull up my context help. So compound arithmetic, it sounds like I can add more than two things. Hey, look, I can stretch this out, value 0, value 1. I can change the mode from plus to multiply, anything that's commutative. So I'm going to try it out. Oh, look, I have, 16 inputs now. Probably not 16. I can change mode to multiply. The bottom three are all Boolean tools that we're not going to use in this class, but if you're familiar with Boolean tools, there you go. You have an AND or an XOR. And all of that was right at in a heads-up display that was just a context help window. So that is the 4 debug tips I wanted to review with you. Have questions? Go ahead and ask.